Hello. Today we are going to learn how to simplify radicals. This is a very easy topic if you understand how to find the factors for the numbers inside the radicals. A simple way of finding the factors is using the factor tree. We will use this method throughout our examples in the video. This example is fairly easy. The number inside the radical is 32 and the factors of 32 are 16 and 2. 2 is already in its simplest form, so we'll just focus on factoring out the 16. The two factors of 16 are 4 and 4, which both factor into 2 and 2. Which makes two groups of 2. And for the square root, if you have two groups of something, you multiply them together, and that number goes outside the radical. So 2 times 2 is 4, so that means the 4 will go outside the radical. And we can't forget about the 2 in the beginning of the problem, and since it's already in its simplest form and doesn't group with anything, it stays inside the radical. So now we'll work on the variable, y to the 6th power. For this, since it's a square root, you find how many groups of 2 you can get out of 6. So for 6, there are 3 groups of 2, which means y to the 3rd will go outside the radical and nothing inside.
For the second example, we're going to be simplifying the square root of 2048x squared. This is a pretty simple one, but it takes some time to do. So the first thing what you're going to want to do is you want to divide it by 2. So you have the factors of 2 and 1024. Now 2 is already simple, but 1024 can be simplified even more. We got 2 and 512. Again, 2 is simple, 512 can go more. So we have 2 and 256. Still, can go further. We have 2 and 128. Even further with 2 and 64. Keep going for 2 and 32. Keep going for 2 and 16. Keep going for 2, 8. Now I know I'm getting to the edge of the board, so I'm going to bring it right back up here. So we have 2 and 8, all right? So now we can go 2 and 4, and then finally 2 and 2. All right? Now that we have all these 2's, all right, now there's a lot, we can start grouping them. So we got 1, 2, 3, 4, 5. 5 groups of 2 with 1 2 left over. Now you may be thinking there's 2 over here, but no, that's just the 2 from down here that I had to bring up. All right. So what you're gonna want to do is you're gonna want to basically start combining the 2's. So you have 2 and 2, which makes 4. 2 and 2, which makes 4, and you're gonna want to multiply these 4's together to get 16. So you have 16. All right. Now you're gonna multiply it by this set of 2, which is our last set of 2. All right, and that's be equal to 32. Right. Now we have 32, which is our simplest factor outside of the radical. So we have 32. All right. Now we can't forget about the x up here. So the x is actually 2 x's because it's squared. So we can take the x and we can pair them together. So we have 1 x because, like everything else, it's 1. It's paired. So we have 32x. Now we can't forget about this last 2. So that goes back inside the radical. Now our final answer is 32x squared. Now a common mistake is people will just be like 2 times 2 times 2 times 2 times 2. That's not the correct way to do it. You actually have to, 2 times 2 is 4, and then 4 times 2 is 8, times 2 is 16, times 2 is 32. All right? So that's just a common mistake people do, but this is the correct way to do it.
For the last example, we will be going over imaginary numbers and cube roots. Our number is going to be the cube root of negative 64x cubed. And since it's a cube root, you have to take 3 factors out of that number instead of 2, which is normally for square roots. So you factor down to 8 and 8. You factor that down to 4 and 2 for both of them. And you factor the 4's down into 2 and 2. And now you have two groups of 3 2's. And then you multiply them together to get 4 on the outside. But since it's a negative number on the outside, you have to take the negative outside. Normally, in a square root, you wouldn't be able to do that because you can't square root a negative. But now, and since we have the x cubed can actually go on the outside, there are 3 x's, take them out, negative 4x, and that's your final answer because the radical goes away.